Hello, Professor. This is Xiaoran from MSBIC. Today I'm going to introduce the work I've done on the kddcup problem. So, first, let me introduce the problem. Well, there are all kinds of intrusions, network intrusions around the world, and to deal with these different kinds of network intrusion, we have to be able to recognize them. Well, it has been a big challenge for people and also for the software to tell from those bad connections from those good connections. So I have to build a model to solve this problem. Usually, those bad connections are divided into four main types, including DOS, R2L, U2R, and probing. Well, to build the model, I have to use the dataset. I've been given the original kddcup data. It includes 24 error classes in the training samples and 16 kinds of types of attacks in the test samples. Also, I found the dataset from NSLKDD dataset. It divided the different attacks into four more error classes, which is more general and easy to divide it, to classify. And so first, I will introduce the work I've done using the original kddcup data. The dataset includes 41 features and one class label. Well, within those features, there are numeric features, also nominal features. So, to deal with this kind of dataset, I think the first function came to my mind is using descending tree because it ignores the numerical or nominal type of data, and it can also make group prediction. Well, due to my experiments, I reached a really high precision, 91.73%, and you can see from the confusion matrix. This matrix indicates the correct answer and compare with my prediction. The data on the diagonal means the correct number of answers that are predicted. And I also reached a very high kappa, 0.8. Wow. Since descent tree is one method to predict this kind of data, I want to use more robotic method like the random forest to make a more precise prediction. However, I found that the result doesn't increase too much. As you can see, the precision is only 91%, and also the kappa is quite similar, and so does the confusion matrix. So I come to do some research on the training data, and you can see that the distribution is very sparse. Only three kinds of features, only three kinds of types of attacks contains a lot. Form the major part of the data set. So, which means, and also it is said that the 75% of the training data is duplicates, and 78% is duplicates in the tested data, which means it will cause our model more bias to those more frequent data type. So our model more likely to predict those like Smurf, this kind of error. If our model leaves out those types there with little test data, well, it won't hurt too much about our prediction, our result. That's why our result is such high. So I think I need to find a more balanced, balanced distributed data set. So I choose the NASL KDD data. It may seem very high, but actually you can see that the top one contains 40,000, but in the previous original one it contains 2,500,000 data set. So data. So I think this one is more suitable for our prediction. And that's why I use the NASL KDD dataset. Before we start to make further prediction, I have to deal with the unseen type. So I think since those unseen types, we don't know which exactly type they belong to. So I think we can use KN algorithm to first divide the training data into 5 clusters into the 4 error types and the normal type. Then we vote for the test data to find the nearest type to the test data. Then we can make assumption that the test data belong to the one which is nearest to it. But to do the KN, we have to make some modification of our data, since KN can only since we use the distance as our matrix. So I have to turn the nominal type feature into numeric, and also for more precision, also scale the data and use the each value in column to divide by the max value in the column, subtract the minimum value in the column. After that, I do the KN and use our NSL KDD plus data. However, as you can see, the precision drops dramatically. Well, this is partly because we use different kind of different training data set to use, and also there's a probability that it may caused by other things, but to make a further judgment, I have to test using other algorithm like the decision tree, and as I expected, it also drops dramatically due to using different kinds of data sets. Well, so but even though it drops dramatically, but I can see that the result from KN and from decision tree doesn't have too much differences. So I began to wonder what caused this. Well, I think since due to the knowledge I learned from Tom Mitchell, it is said if the features in KN exist about 20 features, the algorithm will not perform well. So I think it's time for me to do some feature selection. So I do, based on the data, I've used the normalization. I also remove data with near zero variance. I use R to calculate the variance of each feature, and you can see the last column is whether this feature is nearly zero variance. So I remove those features with true, and at last I got 25 features. I think this time will be better. Yeah, it did increase, the precision did increase, and so does the kappa, but it doesn't increase too much. And also goes the dysentery, it did increase a little bit. So I think this time not only the due to the feature problem of KNN, also it may because of the some features, since we turn it is original nominal but we turn into numeric, so I think these features are not suitable to calculate as distance, and so we directly turn into numeric, and use KN is not quite good. And also I think maybe some features, even though it with little variance, it may plays an key role in distinguishing labels, which means maybe there are some very few type of texts can only identified by those features with very little variance, but just these features are the key to those texts. So I think in the future I need to find a better way to select more useful features rather than just removing those nearly zero features. Maybe I have to test by comparing removing different features, the results of removing different features. And also to rather than just using Euclidean distance to calculate the likelihood between each test data and the clusters, I think I have to come up with a more powerful metrics to judge. And so that's our presentation. That's my presentation. Thank you.